Hi everyone, my name is Tunde. I'm a senior engineer working at VMware. And in this video, we'll be going over recovering from an ETCD failure. So specifically, this demo is going to be focused around a completely lost ETCD cluster, so which is losing majority of the ETCD. Um, so in a case, well, as you can see in the screen, we have three control plane nodes, and what we'll be doing is simulating a failure of each ETCD on each control plane node, and then recovering the ETCD cluster using a snapshot that we would have taken prior to simulating the failure. So let's get into it. So I have three control plane nodes, each one of them starting with the one on the left, which is the first control plane, the second one, the second control plane, the one in the middle, and then the third one is the control plane 3. And then we do have a working node, which we won't be spending time on in this demo. But first, I would like to show you the existing state of the Kubernetes cluster, which is by doing a kubectl get pods in all namespaces, and we can see that the three control plane etcd control plane pods are all running. Another thing we want to make sure is that each control plane nodes are already also, and you can see from the prior kubectl get nodes command that we do have each one of them running. They're all ready and also running Kubernetes version 1.17.0. So the next thing we want to do right now is is to go ahead and take a snapshot of the etcd cluster, or the snapshot of the current key space on this etcd node. But prior to doing that, let's go ahead and verify the etcd member running inside of the cluster, so we can see that each one of them it started. And next thing, we want to verify the endpoint else for each one of these etcd members, and we can see so let me just verify for each one of them by setting the environment variable. So let's set the environment variable for this, and if we run endpoint out, yep, I can see that the etcd members are running on all LT. All endpoints of the etcd members are LT. So great. Now that we've confirmed that, I'm going to set the etcd endpoint back to just the endpoint for the node that we're running on, so that we can successfully run the snapshot command. And we're going to specify the client and the client port, which is 2379. And now I'm going to go ahead and run etcd snapshot save and call our snapshot test.db for the purposes of this demo. So great. The response says the snapshot was saved, and the next thing we want to do is just verify that the snapshot was saved. And you can see here we have the snapshot saved, and it shows it's named test.db. So great, we have a snapshot saved of the current etcd cluster. One thing you want to also notice that we have Nginx running inside of this Kubernetes cluster. And whenever we do a recovery, we want to make sure that the Nginx, that the state still remains the same. So great, we've taken a snapshot, and then the next thing we want to go ahead and do is simulate the failure across three control plane nodes. So first, the way I'm going to simulate that is by just stopping all of the etcd static pods, and I'll start by doing that on the first control plane node by just moving the etcd manifest file from the static pod manifest directory to just the prior directory. So great. At this point, if I run query PS, here we can see that ETCD is no longer running, but if we check here, we should see that ETCD is still running. So great, we have ETCD still running on this node, and let's verify on this node, query PS, ETCD is still running. So what I'm going to go ahead and do in this case is I'm going to simulate the failure also by moving the ETCD manifest file also away from the startup pod manifest directory. Right. So awesome. At this point, ETCD shouldn't be running on this node, right? We verified that ETCD is no longer running, and now the next thing we want to verify is that if we could still get to the cluster by running kubectl to get nodes. So we've started running into issues, but we should still have ETCD running in this case. Great. ETCD is still running, but we want to simulate the majority failure by also taking away this last ETCD container. So we do that by moving the ETCD manifest also away from the static pod manifest directory. So now that we've done that, we should have a total loss of the ETCD cluster now. So we shouldn't be able to talk to the ETCD cluster by, even when we run ETCD call to member list, we should get a context deadline error. So yep, so looks like nothing is running. So now that we've successfully simulated a failure, complete failure, the way to recover from this type of failure is, one thing is ensuring that you have a backup of your existing, or a regular backup of your existing ETCD cluster state. So first thing we want to do is to restore from a snapshot, we would have to first remove the existing ETCD data across the three nodes. So first let's do that. I'm going to go ahead and do rm-rf. So all right, so what we want to go ahead and do is remove the ETCD data directory, remove all the contents of the ETCD data directory. I think it's worth showing what's in each of these directories first. So let's do tree valid ETCD. So you can see we have different snapshots and one DB file inside of each of the data directories that live on each control plane node. So what we want to go ahead and do is remove this data directory var. In my case, my data directory is set as varlib etcd. This could be different depending on your configuration, and I'll show you where to verify what your data directory is. And so now we've deleted the content of the data directory. So if I do tree valid etcd, you can see that we no longer have any data inside of the etcd data directory. So the next thing we want to go ahead and do now is we want to go ahead and migrate the test.db file snapshot that we took here to the subsequent etcd node. And so to carry out that operation, what I'm going to go ahead and do is just copy the command away from my node here. Let's see. Alrighty. Okay, so great. I can go ahead and copy that now. Um, I'm going to copy that. So what I've done here is I've copied the tester.db file from the control plane to node, in this case to my local directory, and then copied the tester.db file into the subsequent control plane node. So into control plane and also control plane 3. And so we can verify that now by looking at each one of the directories, and you can see that they all have a tester.db file. Great. Now we've copied the tester.db file to each of the control plane nodes. The next thing we want to do is restore from that tester.db file. So what I'm going to do is I already have this command pre-populated in the past. So let me just walk you through what these commands are doing. So first, we're specifying ETCD snapshot restore, and we want to change the name of the restore to match what we have as test.db, which is the name of the file. Note, I'm also in the directory where the testers.db live. That's why I just leave this as test.db. If this was in a different directory, you would have to pass in the path plus the name of the snapshot file in this case. So here I'm specifying the name of of each of the ETCD nodes that I'm running this command on. So because I'm on control plane to the name of the ETCD that we're running this restore against on this node is ETCD2, and then we're specifying the initial cluster. Now, it's critical to note that initial cluster here has to match the initial cluster state of the ETCD cluster prior to the majority loss. So in this case, if you had four ETCD members running, you'd have to have the endpoints for each one of the name and endpoint of each one of the ETCD members specified in the initial cluster flag here. And so that's why we have control plane, we have control plane 2, and we have control plane 3, because they were all members of the ETCD cluster as at the point we took the snapshot. And then here we're specifying the initial advertised peer URLs, which is the URL that is being advertised to all other members from this by this control plane 2. And we're using its IP address here, which is 172.17.0.4, and also using the advertised port, which is 2318. So great. One last thing, we're also specifying the data directory as valid etcd. Remember earlier we did we removed all the files from the data directory, and here we're specifying that the restore that we're doing should go into this specific directory. If not, if you don't specify this data directory, what's going to happen is that the restore is going to put a file into the existing directory where you're running this command from. So great, now that we all understand what the std restore command is doing, we can execute on each one of them, and as you can see, we've been able to restore each one of them. It kind of pre-populates and shows you the cluster ID and the member IDs of each one of them and each of the nodes. And so next thing we want to do now is to verify our existing etcd or YAML file to ensure that it's configured correctly to join back to the cluster. So one of the things we want to verify here is the cluster state. So here is specified as existing. It's also specified as existing on the subsequent etcd node. This one should be fine because this was the cluster that we started it with. But one thing that is worth also making a change to is this initial cluster. Earlier when we were passing the initial cluster flag, I had to specify all control plane, ETCD control plane nodes in the initial cluster. So in this case, we only have the first and the second one, so we would have to have the third one on this first node here. So I'm gonna go ahead and do that by, so put a comma and then copy this, for example. And then paste, and then we pass in the IP address of the third control plane node, and also specify the right name for it. So that's pretty much it for this specific ETCD manifest. Let's verify the second one also. So here it says the initial cluster state is this. So what we want to do is just copy from this last one, which looks like it has all the members correct, and we can go ahead and modify this and then paste. Okay, so we have control plane 2, control plane 3 has the right IP address. Now we do have a duplicate here, so we can just switch the first one to match control plane and then specify the right IP address here, which is 05. So great, looks like we have everything corrected, and now we could save on this one also. It looks like we have the configuration right, the cluster state is existing, we don't have any flags like -- force new cluster, which would force the ETCD to create a new cluster. So it looks like we're fine here. So I'm going to go ahead and save. So now that that is done, the next thing I'm going to go ahead and do is, so let's just verify that yes, that the Kubernetes cluster is not, it's not reachable. So I verified on, so we can see across the 3 nodes, I'm unable to reach the Kubernetes cluster. And also if I try an etcd ctl member list, still should, yep, I should still get a context deadline error. So now that we've done that, what we want to do next is we want to go ahead and move those etcd manifests that we moved away to simulate a failure from the static pod manifest directory back into the manifest directory, which is etc kubernetes manifest by default. So I've moved those back, and if we do ls, we can see that we have etcd.yaml back, and if I do call to ps, we should see that each one of them is starting to run etcd again. And now if I run etcd-ctl member list on across the 3 members, we should see that etcd is back up and running. So in this demo, we've been able to look at how to recover etcd from a majority failure, and here is just one of the ways to recover from etcd complete failure. In the next video, I'm going to be walking you through another approach. Leave a like, subscribe. Let me know if you have any questions in the comment section, and if you would like for me to do any other videos, if you have any other suggestions. Thank you.